Hello and welcome everybody to this Syntrotech talk. We are now joined by Stefan Henrich of Stefan Henrich Robotic Design and Architecture, who is Syntrotech technology user since many years now. Hello Stefan, how are you?
I'm fine, Gabo. Thank you. How are you?
I'm very well. I'm looking forward to this fantastic and exciting chat with you. Good. So, Stefan, it's not the first time that we are talking to you. We have basically produced a customer use case with you, and we have done already 2 webinars who have been watched by many thousands of people. So thank you very much again for taking your time. Nevertheless, for those people who do not know you, can you give please a short introduction about yourself and what you do?
Thank you, Gabo. Well, I have this design studio in Stuttgart, Germany. It's called Stefan Henrich Robotic Design und Architektur. And it's a bit also what I do there. I do robotics, design, and architecture. And I have this specialization in design for additive manufacturing, more specifically in SLS. So as a customer of Syntrotech with a S2 system now, I can produce in-house and develop parts in-house. And yeah, that's my new toy.
All right, so thank you very much for this short introduction. Basically, the reason why we decided to do this technology talk with you is that I recently came across with one of your designs that you have printed on our Syntrotech S2 system. So as a person with a technical background, as I am, I was astonished, of course, about its functionality. And I have totally forgotten about the technical term, and you told me it's a so-called compliant mechanism. So could you please explain to the audience what a compliant mechanism actually is?
Yes, so a compliant mechanism is, so to say, an alternative kinematic way to construct. So a common scissor, for example, consists out of 2 rigid parts that are connected with a screw in the center to allow motion, to make a scissor work as a scissor. Now, to rethink the scissor employing a compliant mechanism would make it possible to build the device from one continuous topology, so one part that don't need to be assembled afterwards. So the rotation that enables the motion that happens concentrated in one point would then be needed to be distributed onto larger areas of the part, employing elastic, bendable zones. And the art is, of course, to make the same exact cutting result, or even better cutting results with this new mechanism. Actually, the first scissors or early scissors were constructed as compliant mechanisms.
Okay, good. Thank you very much for this explanation. By digging deeper into this topic, I find a nice channel on YouTube which was called Veritasium. Do you know this one?
I saw this one. I had this conversation with Stefan Noser from Syntrotech lately, and he was showing me this one. I didn't know before. Huh?
All right. Because on this channel, a professor called Larry Howell, I think it was, from the Brigham University, tells the audience or the viewers about how he is using compliant mechanisms to prevent that nuclear weapons can be set off accidentally. So it is used for security and arming, which is basically an awesome example, which I didn't thought about. So if you already watched it, it's okay. Otherwise, we will put the link into the chat for the audience. So I think Professor Howell even wrote a book about compliant mechanisms. It's definitely worth that I'll get one of these examples then. So from your perspective, is there a, so to say, archetype of a compliant mechanism?
Yes, I would say the archetype or the compliant mechanism everyone uses and knows are the tweezers that are used for manicure. It's a very simple example. But also another example could be the fasteners that are used for bags or backpacks, where you squeeze with your 2 fingers to open them. You know what I mean? So these very simple, really widespread, everyday use devices. Huh?
Okay, good. So I think we will put a picture on that the audience sees what we are exactly talking about.
Sure.
So why should one make use of such a mechanism when conventional mechanisms work well enough?
Well, as I said, it's just an alternative way of constructing. But these mechanisms, compliant mechanisms, come with a number of advantages. So, for example, they reduce the number of parts needed to build the mechanism. This, of course, goes along with less assembly, which is time-consuming and maybe expensive. Also, less maintenance is then needed. It is very likely that such a build is easier to clean. So you can imagine a place where hygiene plays a big role, maybe in food fabrication. The food industry might be a good spot to employ these mechanisms. Very often they are very reliable. So you mentioned already this nuclear weapon safety device. Imagine if this mechanism wouldn't be reliable, it could end in a tragedy, of course. Yeah, and also the more reliable a thing is, the less servers it will need over its lifespan.
All right. So basically, it ends up in the reduction of service costs as well. It is speeding up the assembly process, which is no longer given. So that's an interesting point of view on this compliant mechanism constructions. As a huge fan of nature, being most of my free time outside in the nature with my family, I had a nice experience last weekend with a bumblebee. And don't worry, I'm not going to bore the audience about it, but it somehow put me into the direction of bionics. So, do you see any role models from nature for compliant mechanisms?
First of all, I think it really makes great sense to look for these mechanisms, or let's say analogies of these mechanisms in nature. Evolution in general is a fantastic, so to say, inventor, if you want. The first thing that comes to my mind is the so-called fin ray effect. So when you have a look at how a skeleton and the muscles of a fish work together, you can observe something surprising. The construction of the back spine leads to the effect that the fish's tail is bending towards the water stream or the water flow instead of bending away from it, which would be my first intuition, right? So the fish skeleton uses the trick to save energy while moving forward. Yeah, and this principle has been translated into a technical mechanism. That is actually what bionics is doing. And this mechanism works best when it is constructed in one continuous monolithic topology as a compliant mechanism. And there it's used as an example in robotics as a robotic gripper.
Okay. Any other examples off the top of your head?
What else? I think the way now I'm lacking the English word for this animal, the cicade. This little bug emitting this crazy noise during summertime. Yes. I think it produces this noise by moving its upper part of its body shell towards the lower part of the body shell, and I think it's the motion allowed to do this is also a compliant mechanism, but I'm actually not sure.
All right. I will look it up as well. So this seems to be a very interesting example from bionics. So what do you think have these mechanisms to do then more particularly with 3D printing and more specifically with selective laser sintering then?
Well, function integration is a big topic in construction for additive manufacturing, because just the geometric freedom that you gain using 3D printing, you can pack way more functionality, for example, articulations in one single part. Maybe when you construct with conventional fabrication technologies, you are only able to reach this with complex assembly of larger groups of parts. So this is one great advantage of additive manufacturing. And of course, selective laser sintering, as in my opinion, the additive manufacturing technologies that allows most geometric freedom is most suitable here.
So if you compare SLS with FDM or SLA for the functionality that compliant mechanisms need, you think that the selective laser sintering technology is the most suitable for this application case, huh?
It's at least the one I have most experience in. I will admit it. There are nice examples of FDM compliant mechanisms. They also look a bit different. Sometimes they are more 2.5D, but they work pretty well. And you can learn a lot from these. But I think as I said, in SLS with the geometric freedom, you can make them move in different directions in one part. In my eyes, that lies the biggest the biggest advantage. And so,
all right, good. Thank you very much for that. So, coming away or getting away from the technology side, going to the material side, which is also a very important part if it comes down to produce these compliant mechanisms at the end of the day. So what materials from your side, from your experience, do you think are suitable to build a compliant mechanism? Because you know that in selective laser sintering, there's a bunch of materials already existing or given. So what is your experience on this, or what do you think could be one of the materials which has the top advantage in this?
I personally prefer using polyamide 12 because you need a certain experience to predict how a part is behaving. So I have most experience in polyamide 12. That's a durable nylon that provides stiffness and elasticity in one single part. And this can be obtained by adjusting the thicknesses of the construction. So you have the possibility to seamlessly steer the elasticity that you want to get. But also TPU or TPE is materials used in SLS that have rubber-like properties can be employed to construct these mechanisms. Of course, the design would then need to be adapted to the material softnesses. They are, of course, softer, but also I think there's a big potential to be explored using TPU or TPE, for example.
Okay, so do you have a typical or practical example in which fields are they used already? Have you already seen, apart from your work, a compliant mechanism maybe produced on polyamide 12?
I think, as I mentioned before, closures and fasteners are examples. Of course, hand tools like pliers or tweezers. Nice examples explained in this YouTube channel from the professor you mentioned before. But also in aeronautics, there's an example of this beautifully complex-looking jet engine pivoting mechanism that is super lightweight and most important, super reliable, even under these harsh conditions where it has to serve in space, right? But also the field of robotics can profit from these mechanisms. These grippers are examples for that, yeah.
Okay. So Stefan, can you give an example where you have implemented actually a compliant mechanism?
Of course, I did one robotic gripper, a parallel gripper, where I translated all these rotational joints into integral hinges. So there are no joints anymore, but integral hinges. So you have less maintenance. You have one continuous topology. You don't need to assemble all the sub parts to the final part then anymore. What else? I did the design of a wallet from SLS, also with the help of bendable parts or an assembly of bendable parts, all printed in one go. You can call this a compliant mechanism if you want. Let's say a simple compliant mechanism.
Thinking a bit out of the box, what do you think, or do you have any propositions where these compliant mechanisms could be used in the future?
Well, first of all, I think there are many fields where these mechanisms can be employed. Actually, also in combination with SLS as a fabrication technology, I actually should do a list or go through them systematically to see where this is possible. A thing that we can show today would be the bottle cage that I designed lately. That is also containing a
compliant mechanism then?
Of course, a compliant mechanism. It's a bottle cage that is used for a bicycle. It's a cage that actively grasps the bottle as you approach the bottle to the cage, which is pretty useful when you want to drink without stopping your ride. The mechanism is a closure that snaps as soon as you push the bottle over a certain point, and it snaps open when you pull the bottle out of the cage.
All right, good. I think we will see some pictures for our viewers then. Stefan, we covered the technology side, so the selective laser sintering side. We briefly talked about the material side, which both come together to make compliant mechanisms work. A very important question from my side is there, as a construction person, as a person with a technical background, is there any special or specific software that is basically available to help design these mechanisms?
Well, first of all, it is very helpful if you are a good 3D modeler already. And then principally every known 3D CAD software on the market is suitable. So it is perfect when your software provides tools for drawing freeform surfaces. As I mentioned before, the possibility of steering elasticity by gradually adapting the thickness of your construction is important, and that I think can be drawn easily with freeform surfaces. And then, of course, there are engineering tools available for the case that you don't want to rely only on your experience.
Okay. Is it okay to ask what tools you are using?
Of course.
During your daily work?
Yeah. So when I know that the final part will be an SLS part, I really like to use polygon modelers because most 3D printing processes ask you in the end for an STL file. And this is a polygon format, and why not start with a polygon modeler from the beginning? And that's what I do. And I feel most at home in Cinema 4D as a modeling tool when it comes to this task. Yeah.
Okay, good. So maybe one final question from my side. Compliant mechanisms, very interesting. Why don't we see more of those?
I think you're right. That's what I say as well. They are very interesting. Well, I guess that there are just not so many places where this way of construction is taught. Then secondly, the applications are a bit hidden, so they're not so obvious at first sight. So you have to dig for them to employ these mechanisms. Yeah, and that's maybe the reason why only a few people are designing this way. I can imagine that they are getting more, even with the use of 3D printing technologies now. But at this moment, I would say there's potential to see more of them, as you say.
Okay, so Stefan, we have seen these mechanisms in nature, and we are trying to translate them into technical applications. In what field do you see the biggest potential, maybe with the help of additive manufacturing?
Yes, I would say robotics is an important field. In robotics, they are already employed in grippers and end effector systems, but I think they could be employed as well in the main robotic device. So there is potential, I would say. Then, as a trained architect, of course, I'm thinking always about applications in architecture. So a compliant mechanism for an opening device, an architectural element that opens up and closes, could be interesting to explore as well. Yeah.
All right, good. Thank you. So finally, do you have any inspirational sources, tips, or links for our audience where they can dig more into this topic of compliant mechanisms?
Well, the internet is full of this. If you do Google image search, you directly dive into things that you never saw before, maybe.
That's a good point. Yeah, often forgotten. Yeah.
And of course, there's literature about it. One book that is not exclusively about the topic, but it's about generative fabrication with polymers. It's a translation, it's a German book by Jannis Bräuninger, among others, in Springer Verlag. That's something I can really suggest having a look at. Otherwise, if you want to design these mechanisms, just have a look around you and at the objects that are surrounding you and rethink them as compliant mechanisms. That's actually great fun. And of course, you're most welcome to approach me if you have any question or even professional requests for design of these mechanisms. We will figure out what we can do together, right?
Okay, good. I think you have many pictures on your website as well. And this leads me to the end, basically. Thank you, Stefan, for your time. And thank you, everybody, for tuning in. If you have any questions, do not hesitate to contact us via chat or via email. And of course, make sure to visit Syntratec.com. Or if you would like to check out some of Stefan's fantastic designs or astonishing designs, stefanhenrich.de. Stay tuned for more Form Next Action and have a lovely rest of the day.
Thank you, Gabo. Thank you, Syntratec. for having
Thank you, Stefan. Bye bye.
Bye bye.